Uh, maybe, teacher. I
Maybe.
think yeah.
Okay. Maybe it's a good. It's at least maybe it's a good. All right. So probability. Okay. So basically, what is a probability? So let's go back with the basic concept of probability, and we'll talk about what it is. All right. So basically, Paula, please mute your microphone if you're not using it. Paula Ramos. Yes. All right. So what is the basic concept of probability? Yeah. So for example, so probability is a way of understanding how likely it is that something will happen. Okay. So basically, it's like making an educated guess about the future based on what we know. Okay, ini tetong kara dia natane probabilidade ne hane sambe buat tidak kadik metodo ida nebe ita usa atu prehalo predição ba buat sa ida masih acontece iha futuro. Okay, probabilidade ne ajuda ita atu halo an educated guess. Ita halo sasik ida mabe baseia ba iha matemática halo predição sa ida masih acontece iha futuro. Okay, that's pretty much the basic definitions of probability. Now, for example, you're tossing a coin. Yeah, imisoy basi osam basi nene, you're tossing a coin like this. Okay, so my question is, which side the coins will land on? Will it lands on the tail, or will it lands on head? Okay. Agora yan ita bolo ida be numero ihabani ita bolo head, ida be gambar manu siri ihaba, but cafe siri ihabani ita bolo tail. Okay, tiri mini hanoi imi bele sigale. Going na to mono ihat head ga tail. Can you guess? Yes or no? Do you
No.
o sabil hatene gale? Niya say niya mono ya head ga ni mono ya
No.
tail.
No.
You cannot know for certain. Yeah, all abil hatene for certain kata when 100% sure that it will land on her. But however, you can use a probability to calculate or to make a guess. Now, when you flip in a coin, there are two possible outcomes. Ninya be posibilidade ni it will land either in a head or a tail, right? That's the two possibilities. Ninya posibilidade makaruha ni dito na. Mas galay? Either it lands on heads or it lands on tails. Okay, so we can say that both outcomes are equally likely. Equally likely kata nini atuhetan tail ga aw atuhetan head nene scenario nene the chance of both of them occurring are the same. For example, we say that the probability of getting getting heads is 1 out of 2. 2 ne tambah saida, 2 ne tambah o belehetan tail or o belehetan head. Tamutuk nima it does have 2. But probability of getting a head is just 1. 1 of 2. Or we can say there is a 50% there is a 50% probability that we get a head. Comprenden yung konsepto na kale?
Yes, teacher.
Comprende to? So basically, probability gives us a way to describe the situation using numbers. Okay? Probabilidad ne fo ita sa mathematicalmente niya fo dalang ida ba ita para ato describe situação sa ni iha numero ida. A mathematical representation of a certain experiments. That's what probability is. Any questions? Perguntas?
None, teacher.
What about side of probability? Okay, good. Now, the way you usually the expression of probability is usually in a fraction or decimal number between 0 to 1. Yeah. On a probabilidade ne tem que express entre 0 to 1. La vele heta fal probabilidade of negative 1 or 1.2. That doesn't make any sense. Yeah. Dalla ruma probabilidade mos ni representa ya percentage, yes, but mostly ni representa iha ni fraction kar ya fraction, for example, 5 over 10 or just 0.5. So in a fraction or decimal number, second decimal number must be between 0 to 1 only. So if you look at here, for any event A, the probability of A is between 0 and 1, and that's inclusive, yeah? Inclusively between 0 and 1. So mathematically, you can represent 0 less than or equal to probability of A less than or equal to 1. Okay? Basically, hanene, hawakara to probabilidad ne so bele representa yung decimal karik entre 0 to 1 rin. Bele 0.1, 0.123, 2.3, 4.5, 0.45, but la bele liu 1, yeah? La bele heta fali 1.3, 1.4, 3.5. That doesn't make sense. That's not probability. That's not the express values of probability. Comprende?
Yes, teacher.
All right. Any questions so far? All right. So no questions. So, Jesuina, can you read what is an event for us? Jesuina Enegala,
Yes, teacher.
can you read what is on the screen for us?
Even any collection of results of outcomes of a procedure.
Okay, so any collections of results or outcome of a procedure. Ne event wida. Pahire mi kuliah event wida ya. Pahire kuliah event wida ne kan, por exemplo, be imi ba mercado nemos event wida, lo sei. For example, if you go to market, nini resultado si going to market ne saida. Resultado ne saida. Getting groceries. Lo sei. Sosa moro, sosa masing, mas maching, lo sei. Ne nini resultado. Idane evento ida. That's one ane atividade da o evento ida. Los galay. Por exemplo, taking a shower. That's also an event. The result of taking a shower is what? Clean and fresh. Right? Atividades ne evento ida. Ou, por exemplo, so sirane evento ida, like any collections of results or an outcome of a procedure, yeah? Or, por exemplo, nessa ne, sei o que falta. Wait, what's going on? Hold on, give me a second. Okay, so basically, por ejemplo, nidihan sa neto, nidihan be any collection of results or outcome of a procedure. That's an event. Evento ni kata resultado husi procedure da. Okay? Por exemplo, procedure ni sayda. For example, you're tossing a coin 10 times, yeah? For example, you're tossing a coin 10 times. That's your activity. On el resultado ni sayda. You will get a hat or a tail and then the hat, tail, hat, tail, and 1, 2, 3, 4, 5, 6, 7, and hat, tail, and then hat. Nekan resultado, this is the result or an outcome of a procedure. Nekan resultado husi procedurida. So that's an event. Oops. I really hate this thing.
Morning, teacher.
Okay? So now that's what is simple event. Pavan, you read simple events for us.
Simple event, an outcome or an event that cannot be further broken down into simpler components.
Okay, I will give you more example here. So simple event is an event where you cannot break into the simple broken components. I will give you an example in a moment. The next one is what we want to learn about sample space. Okay. Now, what is sample space? Huh? Chidalia, can you read sample space for us? Chidalia,
Yes, sir.
read sample space.
Sample space for a procedure consisting of all possible simple events. There is the sample space consisting of all outcomes that cannot be broken down any further.
Okay, sample space is procedure that consists of all possible simple events. Okay, for example, o yan, kulit an event. For example, tossing a coin 10 times, that's an event, right? The result of tossing a coin 10 times is what? You got a, for example, you got a hat, you got a tail, and then you got a tail, hat, 10 kali lo salah. That's an event. Event ida or actividad ida. Or for example, you're rolling the dice 10 times. Imi besada. Doko kuru-kuru 10 kali ini resultado ni mi belehatan sada. Kuru-kuru rua, por ejemplo, ya. Por ejemplo, kuru-kuru rua ni ida bele 2, ida fali belehatan 5. O dalam ruamos ni bele 3, 4. Ida nene numero sernena sausi. I'm just randomly writing it down, right? But these are all possibilities, right? So this is the result of a procedure. Agora, simple event, nem maka ida letra na bare. Tossing a coin, that's simple event. Tamba, cada evento ida nene simple. Ita la bele fahetang ona ba iha? Simpler litang. So this is a simple event. Okay. This is not a simple event. Tamba, evento ida heneka, por exemplo, ene satu ida nene, satu ho enam ne. O bele se fahetang. Ida hetang 1, ida fali hetang 6. Ida ne simple event. Maybe cada individual ne simple event. Maybe ida ne hamutuk ne not a simple event. Kan ito? So basically simple event. For example, tossing 10 times. This is a simple event because it cannot further break down into simpler components. Right? And then, for example, if you roll in a dice 10 times, this is not a simple event because it can further break down into simple components. For example, the event. Idanene kada evento ida ya. This is all every event that's occurring. Masalah? O doko kuru-kuru dala ida ni hetan 2 ho 5. O doko tan dala ida ni evento ida. O doko tan dala ida ni hetan 5 ho 2. Evento selta. Tapi cada evento ida nene niya belas broken down into simple. For example, hetan 2 ho 5 kali o bela 5 tambah 2 and 5. So 2 and 5 is the simple one, but this event is not simple. The event of getting 2 and 5 is not simple event. Comprende, Kale? I hope you understand this concept. Comprende, Kale? Any questions?
Yes, teacher, comprendo.
Questions?
None, teacher.
Okay, good. Now, so basically, so experimento sila, exemplo sila, how foba iminene, for example, tossing a coin or rolling a die or randomly draw a single card from a deck of cards. Or for example, buat nebe hawakana kimi hatete ne makahatene ne makane ati evento sira ne hotu itala bele hatene ni resultado ni outcome ni sa itala hatene ida. Tamba, there is some sort of uncertainty. It is impossible for us to predict precisely. For example, ane so doko kuru-kuru kare watu halo predição precisely ya. Kata hatene kata oria doko kuru-kuru ne ni semono 5. Ni on label hatene precisely. For example, a sueve or some basic it will land on a head. You cannot know that precisely, right? But however, we can use probability to approximate what the outcome will be. Ita bele usa probability, ita label hatene precisemente, maybe ita bele usa probability ato hatene katak ninya resultado ne sa ida ne ita se bele seek usa probabilidade ato seek. También me te vuelvo seek ne ita latene for certainty. Okay, no. Buat ida nebe ita halo hoy da nene maka ita bazia ba every possible outcome. So every possible outcome neme ita bulunaran sample space. Okay? Now, what is sample space, you ask? Okay, so for example, one more time, toss in a coin. What is all possible outcome of this event? Huh?
Head and tails.
Yes, you can either get a head or just get a tail. That's all the possible outcome, right? All the possible outcome is either you get a head or you get a tail. So your sample space is written out like this. So your sample space is usually written like this. Okay, so S equals to squiggly line, head or tails. That's all possible outcome. What about rolling a dice?
1
Huh?
to 6.
So what is all the possible outcome of rolling a dice? So either you get
1
a
to
1,
6.
you get a 2, you get a 3, you got a 4, you get a 5, or you get a 6. So your sample space is 1 to 6. You get a 1, 2, 3, 4, or 5, or 6. So that's sample space. Okay? Or for example, you randomly selecting cards from a deck of 52 cards. What is the sample space of this? Por exemplo, kartu ni mitakat ya mata e mata rungurangan ti mitakat ya mata. What is all the possible outcome? What is the sample space of this? So the sample space for this will be what? Okay, you can get an ace of clubs, 2 of clubs, 3 of clubs, etc., until king of clubs. Or you can get ace of spade, 2 of spade, 3 of spade, until king of clubs. Maksudnya idenya total 13. Maksudnya 13, nemas 13, nemas 13. So that's all the possible outcomes. That's what you call a sample space. So in order to calculate the probability for something, you need to know the sample space or all the possible outcome, all the possible results that you will get. ¿Comprende todo eso de sample space? ¿Comprende?
Teacher. Yes.
Yes, teacher.
Any questions? Preguntas, Ruma, about sample space?
None, teacher.
All right, awesome. Now, this is the ace, yeah? For example, randomly selecting pitballs. Bola nene na ba? Imi taka tim niya mata lamas tama limang ba? Imi ato 40 bola miyanga usada? Azul ga, mata ga, usada? Kinor ga, laranja. Masalah? Or orange, right? So what is all the possible outcomes? All the possible outcome is red, blue, green, yellow, or orange. Masalah? So that's your sample space. You can just represent it RBGYO, for example. Okay? That's all the possible outcome there is. Now, let's make it a little bit more interesting, right? Now, instead of tossing 1 coin, let's toss 2 coins. Okay? Instead of you flipping 1 coin, you flip 2 coins, right? Now, the sample space, all the possible outcome, never say that. Ida coin pertama ninyo bele land or in head or tail. Ida siguro mo sanesan head or this is the head. This is head. This is tail. And this is tail. Right? Coin pertama mo bele land. If you toss 2 coins, the possibility you can get both coins will get lands on head and head. Or 1 coin is in head. Or the first coin is in head, the second coin is tail. Or the first coin is in tail and the second coin is in head, or both coins lands on tail. So that's all possible outcome. That's your possible. So that's your sample space. Okay. So that's 10 centavos and 50 centavos, for example. Yeah. So 50 centavos can also get you a head on the tail, or 10 centavos also get you head on tail. So your sample space will be these guys. Head, 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 tail, tail, head, and then tail, tail. Okay, so that's sample space, all the possible outcomes. Got it?
Yes, teacher.
All right. Or for example, rolling 2 dice. So instead of rolling 1 dice, you roll 2 dice, right? So 2 dice, 1 dice is 1 dice can get you 1, 2, 3, 4, 5 to 6. Another one also will get you 1, 2, 3, 4, 5 to 6. Now, all the possible outcome, all the results of this event, all the possible outcome of this event is your sample space. Or for example, the first die will get you a number 1, or also the second die get you a number 1. Or maybe the first die will get you a 1, the second die will get you a 2, and so on and so forth. Or maybe the first die will give you a 5, and the second die will give you a 2. Or the first die will give you a 4, and the second die will give you a 6. We don't know that, but that's also possible. So that's all possibility. So that's sample space. All right, so I give you a bunch of examples. I hope you understand what sample space is. Basically, it's all the possible outcomes. Okay. Now, how do you write probability? There's probability. In order to write a probability, there is a certain notation that you need to follow. You can call it some kind of a rule or something. So usually the letter P is what we use to denote probability. When you see a P, that represents a probability. And also we use alphabet like A, B, C, D, E, until Z to represent a specific event. Okay? So when you combine the letter P and the alphabet A, B, C, or D, for example, you write it in a parenthesis like this, you write it like this is how you read it. So P of A denote probability of event A occurring. So that's what it means. So for example, if I write P of D, that means probability of event D occurring. Okay, so A, B, C, D, E, you can use whatever variable. Later on, I'll give you some example on how to calculate, but right now I just want you to understand the basic concepts of probability. All right, so basically we have about 2 or 3 rules of calculating probability. Okay, rule number 1 is what you call a relative frequency approximation of probability, or RFAP. Okay, once again, the first rule of counting a probability is relative frequency approximation of probability. So basically, this rule says that in a certain procedure or an experiment, we count the number of times some event, for example, event A occurs based on the actual result. Okay, so based on, and then you divide it by the total time the procedure was repeated. Okay, what do we mean by that? Okay, for example, you flip a coin 10 times and you get 4 heads. Okay, por exemplo, imisoebe otan besinene, soe dal sanulu, so remember this formula. The number of times A occurred over the number of times the procedure was repeated. Okay, so let's assume, so our event is, for example, I assign letter A of getting ahead, event that getting ahead when I flip the coins. For example, I assign variable A to an event of getting in ahead. Okay, but based on this problem, Maria flips a coin 10 times. So meaning this is the total number of experiment that Maria conducted. And she gets 4 heads. So this is the number of event A occur. Okay, so this is the number of event A occur. So based on the formula that we know, number of times A occur is what? What is the number of times A occur?
4.
4. How many times the procedure was repeated?
10.
10 times.
10.
Okay, so basically, so that's how you represent a probability. So probability of A is equals to 4 over 10, or so probability can be represented like this, which is a fractional form. this is a decimal form. Or sometimes in percentage, just multiply that 100%, you get a 40%, for example. Okay, that's just one simple example of relative frequency approximation probability, or RFPA. Remember that formula, the number of times A occurred over the number of times the procedure was repeated. Comprende? Any questions?
None, teacher.
All right. Michelle Kansa, comprende kalian? Michelle Kansa.
Teacher.
Live pregunta.
Teacher.
Okay, good.
No, teacher.
All right,
Check.
nice. All right, let's go to the next discussion. Okay, what about this? Antonio rolled 2 dice 10 times. And what is the probability of getting the sum of the face up equal to 7? Kata, you're rolling 2 dice and your face up equals to 7. You know what? Get your pen and paper. Let's conduct an experiment together. Okay, get your pen and paper. We'll conduct an experiment together. Okay, can you see the dice over here? We want to repeat the
Yes, teacher.
experiment.
Yes, teacher.
Let's repeat the experiment, I don't know how many times. Okay, we want to get the sum of the face up equal to 7. Let's roll it. If you roll it like this, you get 6 and 2. You write it down, okay? Write it down, 6 and 2. The sum is not equal to 7, but just write it down anyway. 6 and 2, right? That's one event. Event 1. The second, we roll it second time.
Okay, second time.
Okay, write it 5 and 5. That's second event. Roll it the third event. What you get? You get 4 and 3. Write it down.
7,
And then we roll it again, the fourth event. We get 6 and 2.
6 and 2 again.
Okay. Now we roll it again. We get 2 and 6. How many times is this now? 5, right?
Yeah, 5.
Yes,
Yeah,
5
5.
times, teacher.
Okay, 5. Right, one more time. 1 and 6. Okay. One more time. That's 6. Now it's 7 event. 1 and 4. 2 and 6. That's how many now? 8, right?
Yeah, 8.
Yes, teacher.
8. So roll one more time. You get 6 and 6. That's 9th event. And let's roll one more time. You roll it 10 times. So that's 1 and 1. Okay. Now I'm assuming you guys have a list.
Yes, teacher. Yeah.
Hold on.
Yes, teacher.
Okay, so what was the first one?
6 and
6
2.
and 2.
So you got 6 and 2. The second one was
5 and
5,
5.
5,
5 and
5.
5,
and then
4 and
4
3.
and 7.
4 and 3.
4 and 3. And then
6 and 2.
6 and 2.
6 and 2.
2 and 6.
2
2
and
6.
6.
1 and 6.
1 and
1 and 6.
1 and 4.
4.
What?
1 and 4.
1 and 4.
2 and
2 and
6.
6.
2 and 6.
2 and
6,
6.
6.
6 and 6.
6 and 6.
1
1
and
and
1.
1.
1 and 1. So that's 10 events. So we want to know the probability A. We are assigning A as the sum of face-up dice that is equal to 7. Which event equals to 7? So this one is equals to 7. 4 plus 3 is 7. Right? So 1 plus 6
6
is
and 1.
7. So 2 event gets that, so we can write probability of A is equal to how many times event A occurred? 2 times.
2, yeah.
How many times the experiment was repeated? 10 times.
10.
10.
So the probability is 0.2 or
2.
20%. Comprende to?
Okay. Yes, teacher.
Yes, teacher.
Sir, comprehend.
Yes, teacher.
All right, awesome. So that's the simple example that we do. Oops.
Madud po ano, madud kare kita lor ba so no dago matame ko no.
Okay. What about this? For example, you have an event of having a like blood donor. Yeah, you have like 100 people donate their blood. Okay, so the frequency table according to the blood type is as follows. For example, there are 35 people who donates their blood, and they have blood type of A. And 20
Leon,
people
Tasha,
have a
ano
blood type of B. Jose da Costa, please mute your microphone. If you don't want to go to class, just leave and don't bother other people. Jose da Costa, no nagale. All right, so blood type A is 35. And then blood type B, there are 20 people. Blood type AB, there are 20 people. And blood type O, there are 35 people. Okay. Now, we are still using the RFPA, relative frequency approximation of probability. Well, find the probability that the person has a type blood O type. So we can just simply write P probability of O, yeah, getting a blood type of O. Okay. How many times this event occurred? You have 25 times.
25.
25.
And then how many times the event of blood donor occurs? There are out of 100 people.
100.
100.
So you got a 0.25%, 0.25 probability. What about find the probability that a person has a type A or type B blood? So the way you write an OR statement is probability that the person has a type A or type B is simply written as probability of A plus probability of B, blood B. So what is the probability of a person has a blood type A? That will be 35 over 100. And B is 20 over 100. So the total of that is what? 0.55 probability. Okay. Now, the C is find the probability that the person does not have a type A or type B. When you say does not type A or type B, nor type B. So that means they are either A, B, or O, right? So we can just simply write probability of A, B, or O. So be careful. So that means probability of A, or later on we will study about the probability of addition, but this is just a introductory example. There's much more. Probability of addition is plus probability of B. So that will be just what? AB is 20 over 100 plus O is what? 25 over 100. So you get approximately 0.45. Right? So yeah,
Yes, teacher.
that's how you count the probability. That's the rule number 1. So basically, What's the formula for rule number 1? The number of times event A occurs divided by the total number of procedure, yeah? Was repeated. Any questions about rule number 1?
None, teacher.
Okay, good.
No, teacher.
Now let's go to rule number 2. Okay. Now rule number 2 is a bit different than rule number 1, but I think so. Assuming you have a given procedure, one given procedure has n different simple events, and that each of those simple events has an equal chance of occurring. If event A can occur in S of these n ways, then probability of A is number of ways A can occur over number of different simple events. Okay, now before we go into that, I want to give you what do we mean by equal chance of occurring. This is a very important concept in probability. It has to have an equal chance, meaning if you flip a coin, getting a tail and head has an equal chance, yeah? Kita halo be tail ida makwano be coin ne makaladung balanso, yeah? Meaning soring ida makbot li soring ida be ida red maka silent o soil 500 kalimos 50 muselet. That's not an equal chance of occurring. That means something's wrong with the coin. But if coin is normal, then they have an equal chance of occurring. Or for example, same thing with the die. Or every possible outcome has an equal chance of occurring. 1, 2 to 6 has an equal chance of occurring. Right? So, for example, imi hili multiple choice question be A, B, C. Imi lahat yan resposta imi hakarak sigdit. Terus kaya, imi to hili B, A, ga, B, ga, C, ga, D, nene. Opção had nene niya iya posibilidade imi bele hili salah satu ni ida no sira. Opção had nene niya probabilidade de imi si hili ne hanesan hoto. That's what we mean by equal chance of occurring. Okay, this is a very cool example I want you to, I want us to do, okay? Pay attention to this example because this is explain a lot of the concept of probability here. All right. So for example, imi ato ba visita be familia ida ni uma. Okay? Imi hatene katak familia ne ia oang na intolu. Maybe imi lahatene husi oang na intolu ne feto hira mane hira imi lahatene ida. Tami imi sidag ba visita. Maybe imi hatanet informação katak familia ne ia oang na intolu. Okay? Just imagine that. Now, probabilidade sa ida maka husi oang na intolu ne oang na irua ne mane. Okay, for example, what is the probability that they have 2 boys? Now, we can use probability to calculate, or you can guess, yeah? You can use probability to approximate your predictions. Okay, how do you go about it? Okay? O hingi dali datang, ito niya be classic be probability na sada. For example, I let A be the event of have 2 boys of the 3 children. Okay, kata kiawa na intol ni how assume te ane mak eventu ida nebe husi oa na intol ni na irua ne mane. Okay, husi be classical probability ni diyan saida. What is the formula? S is what? What is S? S over N,
N.
right? So we say S is what? The number of ways A can occur, a number of different number of all possible outcomes. Okay, so for example, the number of ways A can occur, and then all the possible outcomes or sample space over the sample space. All the possible outcome, yeah? Now, how do you determine the sample space of this How do you, imi idea numa? Saya natin, isami tayo sample space of this event, of this situation over here. Any ideas?
3.
What? Saya dah tells you.
No, I'm just
3.
guessing, sir. Sorry.
Okay, now let's ask first. What is the option? Okay, the first children. What is the outcome? Just the first children. It's either a boy
Boy
A
or
girl?
or a
girl.
girl. Let's get it. That's a first. Let's get it. And
Yes.
and then the second child. That's also a possibility of
A boy
a boy or a girl. Same thing. Let's get it. Boy or a girl.
Girl.
That's the second. Now the third child also, it's either a boy
Or
or a
girl.
girl, boy or a girl, boy or a girl, boy or a girl. So your sample space becomes
8.
so sample space. Oops. So your sample space, either you get a boy and boy. So either you get the first child is a boy, second child is a boy, and the third child is also a boy. So you will get boy, boy, and boy. Or the first child can be a boy, the second child is a boy, but the third child is a girl. Boy, boy, and girl. Or the first child is a boy, the second child is a girl, and the third child is a boy. So you get boy, girl, or boy. Or you get the first child is a boy, the second child is a girl, and the third child is also a girl. Boy, girl, and then girl. Okay, that's all possibility. Or you can also get the first child to be a girl, the second child to be a boy, the third child will be a boy. That's one possibility. Or the first child is a girl, the second child is a boy, but the third child is a girl. Right? Or the first child is a girl, the second child is also a girl, but the third child is a boy. Right? Or you can get the first child is a girl, the second child is also a girl, the third child is also a girl. This is sample space. This is your sample space. This is all the possible outcomes. Let's get it. Agree? Everybody agree? Sample space.
Yes, teacher.
Okay, so that's all
Yes,
possible
teacher.
outcome, yeah? Now, so how do you calculate the probability of A? Okay, how many number of ways A can occur? How many ways that A can occur? So when you look at each individual events, which event that have two boys?
Event 1.
This one has two boys, even though it's all three boys, but at least there is two boys. This one also have two boys. This one also have two boys.
2 boys.
This one also have two boys.
2 boys.
That's it.
4.
Right? So your
Yeah.
probability is
4.
4 over how many? What is the sample space? 1, 2, 3, 4, 5, 6,
8.
8.
Or 8.
So that will be what? 0.5. ¿Comprendes, no?
Yes, teacher.
By the way, can you guys see my screen, what I'm writing here?
Yes, teacher. It's clear.
Okay, good. All right. So comprende, yeah? So that's a simple example of a classical probability of classical probability. So now you know about rule number 1 and rule number 2. Rule number 1 is how many times event A occurring over the total number of times the procedure was repeated. And the rule number 2 is how many ways can event A occurring divided by all the sample space or all the possible outcomes. Can you guys differentiate between the two? ¿Ya preguntas, Ruma? Or let's do one more example on this. Okay, what about this? Now, what is the probability of randomly drawing either an ace or a clubs from a deck of 52 playing cards? Okay, so how do you go about this? What is the probability? Let's suppose I write an event A as an event where I draw a card ace. So ace is ace of clubs, ace of spades, ace of heart, and ace of diamond. Or event B is either I get clubs, draw clubs. So I get this guys all until all of these guys. Right? What is the probability of that? So that will be so let's start with what is probability of drawing an ace? How many ways, right? So how many ways can event A occurring? Huh? How many ways can event A occur? Four, right? So
4.
it's an ace.
4.
Ace can be clubs, spades, hearts, or diamond. Okay.
4.
How many? What is the sample space? Or what is all the possible outcome? That's all the 52 playing cards.
52 playing cards.
So that will be 4 over 52. That is what? About 0.077. Now, what about probability of drawing clubs?
13.
13.
13, right? Over 52. That'll be about approximately 0.25. ¿Comprende? Questions? ¿Preguntas?
None, teacher.
Good. Okay. Okay, what about this? In our statistics class, for example, we have a total of 13 students, 6 of which are female and 7 are males, for example. Now, if I were to choose one student to represent JSU in public debate, what is the probability I will choose a girl? How will you calculate this? So we have total of 13 students, right?
13. Yes.
And then 6 are females and 7 are males. So let's suppose A represents an event of choosing a girl to represent at JSU for the debate team. So what is the probability that I will choose a girl? How many ways can A occur? How many ways can I choose a girl? There are 6 different girls, right? Either Maria, Antonia, etc., etc., Natasha, or something. So there are 6 different ways of choosing a girl. How many possible outcomes? What is the sample space?
13.
13.
There are 13 possible ways. The possibility of choosing 13. So that will be 6 over 13. Then you will have about 0.46 probability. Okay? So I hope I hope with this example you are at least understand the basics concepts of probability. Bas galay? Bele comprende ya?
Yes, teacher.
Good, good, good. All right. Now, any questions so far? Okay, again, ya, sa imi rumah ya perguntas rumah, maka ako explique era may mga perguntas, just stop me, ask the questions, I don't mind, okay? Just to let you know. Okay, now we are going to complementary events. So, if you can read here, complementary events means the complement of A, or denoted by A bar, consists of all our outcome in which the event A does not occur. Okay, so complementary usually represented by this symbol with the hat, or not a hat, with the line on top of a letter. Okay, so basically, if you know the probability of A, then you can calculate the complementary of that A. So you just have to minus 1 minus P of A. Okay, so probability of getting an A is just, so what do I mean by that? So for example, 1,010 United States adults were surveyed and 202 of them were smokers. Por exemplo, sila halos survey dahil sa Estados Unidos, sila total be sample naman eh, 1,010 people who they were surveyed. Okay, kung si sir niya survey ne, sila hetang katak 202 of people are smokers, fuma sigaro. Okay, so if you want to calculate what is the probability of smokers, you just put 202 over 10 and 10, right? That's the total sample, and you get 0.20. Now, probability of, what is the complementary? What is complementary is the antonym or terbalik falim. If you're a smoker, then the complementary of a smoker is what? Non-smoker. Right? Not a smoker. Or for example, if it's raining, what is the complementary of raining? Not raining.
Not rain.
Okay, if you have a Nike, the complementary of Nike is
Days.
evening or dark, day, sorry. Night and day. If let's say if you have a females, the complementary of females is male.
Male.
Okay, so that's what complementary. So if you find one, you can use that to find the other one, the complement. That's what you mean by complementary probability. Okay, for example, according to weather prediction, there is an 80% probability that it will rain today. Okay, so probability, let's assume, let's write, now let's write A as it will rain. Okay, so probability that it will rain is what? 80%, that means 80
80%,
over
yeah.
100, yeah? That's 80%, or approximately 0.8. Okay. So what is the probability that it will not rain? Okay, complementary. So probability of A but not rain. A with the strap on side, that to just indicate the probability. So the formula is 1 minus the P of A. So all you need to do is plug it in. 1 minus P of A is 0.8. And then you get probability of not raining is
0.2.
0.2. So basically, it's very simple example that it will not rain. Okay, so this is the calculation that I've done, but anyway. Okay. What about this one? In a test of multiple choice, you have a choices of A, B, C, and D. Now, what is the probability of being correct? Being incorrect? What is the probability of being incorrect? Now, before we answer what is the probability of being incorrect, So what is the probability of being correct?
3.
1.
No. Why 3?
Four.
It's 1. In a
One,
multiple
okay.
choice, that's like a multiple choice ni bye-bye hira. Only one answer is correct and the rest is not correct. That's right?
Oh,
So,
yes.
so probability of choosing a correct answer right now agora is what? Is 1 out of 4.
Four.
Or equals to 0.25. Now, the question is not probability of getting a correct answer. The question is, what is the probability of being incorrect? So the probability of being, let's say, let's just
0.6.
represent, yeah, let's just represent this with a letter or something. Okay, probability of being incorrect is, let's say I represent the Z with an correct. Probability of Z, probability of incorrect is Z bar, so 1 minus P of Z, which is 1 minus 0.25, you get 0.75. So probability of getting correct is, probability of correct is about 25%, and probability of choosing incorrectly is
75%.
75%. Now my question is, does it good idea when you have an exam just to guess like this?
No.
No, because the chances of
Oh.
you being incorrect is very, very high compared to the chances of you being correct. If the choice is just A and B, or true or false, then yes, the chances is very, very high to get a correct answer. Right? ¿Comprende, ta? ¿Preguntas?
Yes.
Any question?
No.
All right.
teacher.
Now that you understand the basic concepts of probability, now let's study about the addition rule of probability. Okay, now we are going to study about the addition rule. Okay, earlier I've shown you some example of the concept of addition, but this specific section of the lecture we will talk about the addition rule. All right, so now before we can understand about the addition rule, we'll have to understand first what I call a compound event. So compound event is any event combining two or more simple events. That's what you call a compound event, yeah? For example, o takulitin, two or more, probability of A or B. O combining two events to hamutu, that's what you mean by a compound event. So for example, if I write this notation, P in the parentheses of A or B, that means probability in a single trial. That is very important. One single trial, the event A occurs, or event B occurs, or they both occur. Okay. For now, this is just I will give you an example in a bit. Just simply, I want you to understand is compound event is where you have two events that's combining in a single experiment. Okay, that's what you mean by compound event. Now, Euphrasia, read this for us. General rule of compound event.
When finding the probability that event A occurs or event B occurs, find the total number of ways A can occur and the number of ways B can occur, but find the total in such a way that no outcome is counted more than once.
Yeah, no outcome is counted more than once. So, for example, if we go back away, example, you have a cartoon abane. I want to go back, but yeah, this one, this example. Agora, itaninia event A na sada, drawing an ace. Los gala ace na maneta na. This one, this one, this one, and this one. Itani event B, ne drawing clubs. this one, 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 this one. So may be, yeah, ace of clubs sila nene niya repetete na. Iha eventu amos niya tama. Iha eventu bemos niya tama hotu. Maybe by here ita kuliah ko na ba probability of addition we want to avoid that. We don't want to double count it. That's what the rule says. That's what if Raja was reading out. That's what it said. Okay, so this is what we mean by general. So when finding a probability that an event A occurs or event B occurs, find the total number of ways A can occur and number of B occur. But this is very important. But find the total in such a way that no outcome is counted more than once. And as an example, correct, it an ace of clubs is counted more than once already. Right? So that's just general rule for addition, yeah, for compound event. Now, because of that, this leads to a concept of if pernah poti ya pre-calculus mistura kon ba sets, yes or no? Venn diagram.
Yes, it's
Yes.
You study about Venn diagram in pre-calculus, right? So basically, so if you have two events, event A and event B, are disjoint, katak sirnaro nila exclusive ida. They are mutually exclusive. Nitable that a disjoint event. Nema ka ida nene. This is a disjoint event. Probability of A, probability of B. Laihe ida maka sirnaro eventu aho bene, laihe ida maka common, yeah? Laihe eventu, yeah, single event, ida maka join. That's what you call a disjoint event. Joint event, na maka ida nene. Sirnaro nene iha this overlap over here. Katak, there are some members of the sample space that occurs in both event A and event B. Okay, so iha be halo adi samba probability ba iha join and disjoint event and then in your formula ladong hanesang. Okay, so for sa banghira ito ni event na maka-joint event, berarti probability of A plus probability of B. You need to minus 2 probability of A and B. Okay? Sa karik scenario ni event na joint event, the last aspect of the formula just removal. Just simply probability of A plus probability of B. All right? Join and disjoint event, different formula. Just the only difference is the last part of the formula. Okay, example. All right, for example, what is the probability of randomly drawing an ace, either an ace, probability of drawing either an ace or a heart from a deck of 62 playing cards. So let's suppose I put A as drawing an ace and B as drawing a heart. Okay. Now, what is this a joint event or a disjoint event? Let's see. Ace. What is the drawing an ace? So you have this is the ace, right? And then you also draw in hearts, right? So is this a joint event or just this joint event?
joint event.
Joint event because this A is occurring in both event A and event B. So you will use the formula probability of A or B is equals to probability of A plus probability of B minus probability of A and B. Okay, you know what is the probability of A? Probability of drawing an ace, that's 4
Yeah.
over 52. What is probability of B? Drawing a heart, you have 13.
13.
Minus probability that event that have occurs in A also in B, that's just one event. Comprende, Gale?
Yes,
So that
teacher.
will be
Yes.
14 plus 13, that's 4 plus 13, that's 17 minus 1, that's 16 over 52, or approximately 0.31. Okay, 0.31. Okay, that's an example of a joint event. What about this one? What is the probability of randomly drawing either a heart or a clubs? Or for example, I put a letter A for drawing hearts or B for drawing clubs. Okay, so drawing a heart is this, right? This is drawing heart. And drawing clubs. Where's clubs? Clubs is here. They are mutually exclusive, right? They don't have anything. So this
Yes.
is a joint or disjoint event.
Disjoint.
Disjoint event. So probability of A or B is simply add them. Probability of A plus probability of B, which simply equals to probability of A is 13 over 52. Probability of B also 13 over 52, which gives me 26 over 52, or approximately 0.5. All right? But that's only just, so far we are only combining two events. But what happens if you have you want to combine 3 events? What about this one? What is the probability of drawing a card from a deck is either a king, drawing a king, a queen, or a diamond? Okay, I'm just gonna let letter K be a king, Q drawing queen, and D drawing diamond. Okay, now how would you do that? Okay, what is the probability of drawing a king? Yeah, so the drawing a king will be all these kings. 1, 2, 3, 4. That's all the possible. What about drawing a queen? The
Queen,
same thing.
diamond.
Queen is also this one. That's 4 possible ways. What about drawing diamonds? The diamonds is this one. Right? All of this are all diamonds. Okay, so how will you find the probability of K or Q or D? So you simply probability of K plus probability of Q plus probability of D minus probability of K and Q and D. What is the probability of choosing a king? That will be 4 over 52. Probability of choosing a queen, that's also 4 over
4.
52. Probability of choosing a diamond,
13.
13.
13 over 52 minus this. So there are two things that join, right? The
Yes,
queen
yes.
and the
Yes.
king of diamond is repeated. So you have to minus 2 over
2
52. That's how you make sure that you cannot count it more than twice. So 4 plus 4 is 8 plus 13. That will be 21 minus 2. That will be 19 over 52, which is approximately 0.37. Right. Okay, comprende?
Yes, teacher.
Yes, teacher, comprehend.
Questions?
None, teacher.
Okay, good.
Nope.
What about this? There are 11 pit balls in the bag. What is the probability that getting a blue ball or a red ball? So let's say I'm assuming I write letter B to represent blue ball, and I write R to represent red ball. What is the probability of getting a blue ball or a red ball? Now, my first question, is this a joint event or is this a disjoint event?
Disjoint, teacher.
Disjoint.
Disjoint, because red and blue have no relationship whatsoever. So you just have to combine probability of blue plus probability of red. Then so blue, how many blues do you have? 5 over total.
5.
1, 2, 3, 4, 5, 6, 7, 8, 9.
11.
11. Plus red is 3 of 11. So you
8
will
over
get
11.
about 8 over 11, which is approximately what? 0.72. Okay, that's very simple example. What about this one? Now, 100 students were surveyed about the about their preference between face-to-face class and online class. Okay, the following two-way table displays data for the sample of students who responded to the survey. Okay, there are 36 males who prefers to have face-to-face class and 20 female who prefers to face-to-face class. But there are 10 male who prefers an online class and 26 females who prefer online class. There are 2 students, 2 male students that remain neutral. They don't prefer either. They're fine with either. Or 6 students are fine. So the total 36 plus 20 is here. The total is over here. And the total of everything is 100 students. Now, letter A. Find the probability that a randomly selected student prefer face-to-face. So let me just write F as a face-to-face. Letter O to be online. And letter N to be neutral. So the question let of A is find a randomly select prefer face-to-face class. What is the probability of face-to-face class? Anybody looking at the table?
56.
Yes, 56. Very good. Because it's the face-to-face. 20 and 30 combines a total of 56. That will be 56 over 100. So
100.
equals to the probability is 0.56 or 56% probability. Okay. What about this? Find the probability that a randomly selected student is male and prefer face-to-face class. Probability that a randomly is okay, so I represent M to male and F to female. Oh, just put FE, yeah. Oh. Instead of putting an F over here, let me just put a different, just Q for female. Okay. Now letter B is find the probability that a randomly selected student is male and prefer face-to-face. Male and face-to-face. Which one is that? Face-to-face but male. That will be 36.
36.
Male and face-to-face. So now you just look into. So now you're just looking probability that male and prefer face-to-face class. That will be
36.
36 over 100 equals to 0.36. What about the C? Find the probability that a randomly selected student is female and prefers online. Is female and prefers online class.
20.
Huh?
20.
Female
26.
26, yeah.
22.
So that will be 26 of 100, which is equals to 0.26. All right. So, any questions so far?
No, teacher.
None.
Alrighty. Okay, what about this one? In a group of 101 students, 40 are fourth year, 50 are female, and 22 are female first year. Find the probability that a student picked from this group at the random is either a first year student or a female. Okay, so let's write out the total of 100 students. Total is 101 students. So you have 40 are first year. And then 50 are female. Well, let me just F
22.
Y here. And then this one is just L, F. And 22 are female and
Yeah.
first year. Okay, so what is the probability? Probability that the student picked from this group is either first year or female. So first year is what? What is the
22.
probability? Is this a joint event or disjoint event? The joint event. So probability of female first year is plus probability of female minus probability of female and first year and female, right? So this is a joint event. So probability of first year is 40 over 101 plus 50 over 101 minus 22 over
22 over
101.
1.
So 50 plus 40 is 90 minus 22, what will be 68 over 101, which is equal to 0.67. So this is your answer, 0.67. So there is a very high probability, there's a 67% probability that if you randomly pick a student from this group, there is a 67% probability that you will pick first year student and she's a female. All right. ¿Hay preguntas? Any question?
No.
None.
No, teacher.
All right. Well, the next topic is multiplication rule. But I think we can continue this next meeting. Because lecture 4 is a lot. We have about like almost 100 slides. So we are just in slide number 38 now. Next week we can continue with have you guys seen the homework number 3 I posted? Did you receive an email about it?
Yes, teacher. I saw it in the classroom already.
What?
I saw it in the classroom already, teacher.
Okay, good. In the classroom. So I also I will upload a video. I just upload a bunch of videos on YouTube today. So I might also put the link on the classroom also. So just check that.
Teacher, if I can ask, will teachers send the lecture number 3 as well in there?
Yeah. I will upload it. Yeah.
Okay.
Okay, let's take an absence first.